slope of a tangent line to a curve is one of the interesting topic in basic calculus. So for the objective of this session, we have to recall the slope of a line, illustrate the slope of a tangent line to a curve, find the slope of a tangent line to a curve, and find the equation of a tangent and normal line to a given curve. So first we have to recall again the slope of the line. So we can define the slope of course by rise over run, and then so this is rise over run, or the delta y over delta x, and of course the formula that our students already know is xy squared minus y sub 1, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in recalling the slope of the line, so we have to consider point P and point Q, and the coordinates of point P is 6, 10, and Q is 3, 3. So using the formula, so we have 10, so this is 10 minus 3, and over 6 minus 3. So the slope of this given line is 7 over 3. So any 2 points, or given any 2 points on the line, so we can determine the slope. Okay? So another concept that we need to recall is the secant and tangent. So the tangent line to a circle, so the students are familiar with this. The tangent line to a circle, it is a line intersecting a circle at exactly 1 point. And a secant line to a circle is a line intersecting the circle at 2 points. So let us consider this figure. So this line L is tangent line, for it intersects a circle at exactly 1. He or she is looking ahead. So, for instance, the passenger is here. So here at the wagon, sitting at this wagon. So the line of sight of a person is here. And this is parallel to the tangent line at this point. So if we consider this wagon and there is a passenger here, that's the line of sight of the passenger is this, and this is parallel to the point on this car. So if we consider this curve in a roller coaster, okay. So let us predict what will happen to the slope of the secant line as point Q gets closer and closer to P. We will visualize what will happen to the secant line using GeoGebra. So if we have point Q and point P and this as a secant line, so what will happen if point Q approaches point P? So let's say we have point Q sub 1 here, and let us look at the secant line and look also at the slope or the change in y over change in x. And if we have another point Q sub 2 closer to point P, and if we are going to get the secant line, so look at this secant line, and then the slope or the value of the slope, the delta y over delta x. So as you can see, the slope becomes smaller and smaller, or the delta x becomes smaller and smaller. And let's have a point Q sub 3, and let's take the secant line, and this is now our change in x, change in y over is the limiting position of all the secant line QP as Q approaches P. That's why we have to use the limit to find the slope of the tangent line. So that's why it is very difficult to discuss the slope of the tangent line without the limit. So therefore, again, the slope of the tangent line is the limit of delta y over delta x as delta x approaches 0. So let us derive again the formula for finding the slope of the tangent line using this secant line. And we all know that the tangent line is the limit of the slope of the tangent line is the limit as delta x approaches 0. So if we have point P whose coordinate is x, f of x, and we have if this is x and this is delta x, therefore point Q now is the coordinate of x of point Q is x plus delta x. And then, of course, the coordinate of y is f of x plus delta x. So we have delta y. So this is f of delta x. This one, f of x plus delta x minus this f of x all over x plus delta x over x. And then if we simplify the denominator, we have f of x plus delta x minus f of x over delta x as delta x approaches 0 is the slope of the tangent line. So let us formally define the slope of the tangent line by the slope of the tangent line to the graph of a function f at the given point p x of f of x is given by this formula. Provided that there is a condition here if the limit exists. So if the limit does not exist, maybe the function at that point is discontinuous function. So again, the condition is if the limit exists. So let's take an illustrative example. So find the slope of the tangent line to x squared minus 1 at point 2, 3. So let us use the definition. So we have our function is x squared minus 1. So we plug in for the x in x plus delta x. So e squared minus 1. So this is f of x plus delta x minus 1. Then minus the original function, which is f of x, and that is x squared minus 1 all over delta x as delta x approaches 0. So we have to square the binomial. So we have x squared plus 2x delta x. So we have shortcut here by using the formula a squared plus 2ab plus b squared plus delta x squared minus 1. And then we have here negative x squared. And then negative times negative 1 is positive 1. So therefore, we have x squared here, and this is negative x squared, and then negative 1 plus 1. Then we have 2x delta x plus delta x squared. And then if we factor out delta x here, so we have 2x, and then delta x here we have delta x. So we can cancel this delta x over delta x. So what will happen is the slope of the tangent line is the limit of 2x plus delta x as delta x approaches 0. So if we get the limit of this, so as delta x approaches 0, so this is 0. So we have the slope of the tangent line is 2x. So this is the slope of all the tangent line to the graph of x squared minus 1 in general. At 0.23, so we have 2. Our x here is 2. So 2 times 2 equals 4. So the slope of the tangent line at 0.23 is 4. So let us check using GeoGebra. Okay. So this is the graph of x squared minus 1, and we want to determine the tangent line at 0.23. So here we have 0.23. Then we can draw the tangent line to this curve. So this is the tangent line. And let us determine the slope. There. So the slope is 4. Okay. Since the slope in general of this curve is 2x, so what about if we have another point on this graph, which is negative 2, 3, and another point on the curve, which is negative 3, 8. So let us try to determine the slope of the tangent line to these points. Okay, so this is our first example, 0.23. So at point negative 23 here, so let's get the slope of the tangent line. So we have 2x, and then using point negative 23, so we have 2 times negative 2. So the slope is negative 4. What about if we have point negative 38? So getting the slope of the tangent line at that point, we have again 2x. So we have 2 times negative 3 equals negative 6. So if we will check, so let's have tangent at point C. So as you can see, this is the line tangent at point C. And the slope is negative 4. And then if we have a tangent line at point negative 38, so this one, so the green one, and let's take the slope. So the slope is negative 6. So our slope is correct. Okay. Okay. So since we have the slope of the tangent line and we have a point on that line, so we can determine the equation of the tangent line. So given the slope, which is 4 and 0.23 on the line, so equation of the line can be determined using the point or the slope intercept form. So we can also use the point slope form, but for this presentation, I'm going to use the slope intercept form. So we have point at 2, 3. So this is our So we have, this is our y and this is our x. So we have 3 and our slope is 4 and multiply by 2. So x plus b. So 8, 3 equals 8 plus b. Therefore, b is 3 minus 8. So b equals negative 5. And to get the equation, So we simply substitute the slope, which is 4, and the y-intercept at this y equals mx plus b. So the equation is 4x minus 5. Then similarly, we can determine the equation of the normal. So by getting the information from the slope of the tangent line. So if we say normal line, we have this is the line perpendicular to the tangent line at particular point. So if the slope of our tangent line is 4, so the negative reciprocal of this slope is the slope of our normal line. So if the slope is 4, the negative reciprocal is negative 1/4, and it is passing through 0.23. So using again the slope-intercept form, we have to plug in the x and y and the slope. So 3 equals negative 1/4 yung slope, and x is 2 plus b. So we have 3 equals negative 1/2 plus b. So we have 3 plus 1/2, and that is 7/2. So the equation by substituting the slope of the tangent line, negative 1/4, and our y-intercept at our formula of or the slope-intercept form. So we have the equation y equals negative 1/4 x plus 7/2. So let's have example number 2, but this time, so we have the square root function, which is 3x plus 5, and we're going to find the slope of the line tangent to this graph at 1 is square root of 8. So if we plug in 1 here, so we have square root of 8 is our y. So by using the definition again, so we have square root of f of x plus delta so x plus so x 3 square root of 3 we have here x plus delta x plus 5 minus the f of x. Our f of x is 3x plus 5 over delta x. Then we have to rationalize the numerator by multiplying by its conjugate as well as the denominator. We have this one, and then so we have here square root of 3 quantity x plus delta x plus 5, and this is minus and this is plus. So we have now square root of 3 multiplied by x plus delta x plus 5 squared. So we can cancel this square root because we have a squared here. So what will happen? So we have the 3 times x plus delta x plus 5 minus 3x plus 5, and then if we multiply the denominator, so delta x multiplied by this one. Then, so let us simplify the equation. So by distributive property, we have 3x plus 3 delta x plus 5 minus 3x minus 5. So we have 3x here minus 3x, and then plus 5 minus 5. So the remaining equation is 3 delta x all over delta x times square root of 3 times x plus delta x plus 5 plus square root of 3x plus 5. So we can cancel delta x. So it becomes 3 all over our denominator. And we will get the limit as delta x approaches 0. So this delta x is 0. So we have 3 over 3x. X plus 0 is x. So we have 3x plus 5 here. And then plus 3x plus 5. As you can see, we have 3 all over square root of 3x plus 5. So we have 3 all over 2 times square root of 3x plus 5. At 1/8 or at 0.1 square root of 8, we have to plug in 1 for our x. So we have 3 times 1 is 3 plus 5. So that is 3 all over 2 times the square root of 8. And if we simplify this, we have 3 all over 4 square root of 2. And that is approximately 0.53. So if we have to check, so let's check. Let us check using GeoGebra. There. So this is the graph of square root of 3x plus 5. And then at point 1, we have name and value. So this is 1 is square root of 8, and that is 2.83. So this is our point. And if we draw the tangent to this point, or the tangent line to this point, so we have here the tangent line. And if we get the slope, so that is 0.53. Okay. And then the example number 3 is different from the other two. It says show that the tangent line to f of x, which is equal to 2x squared minus 12x plus 1 at point 3, negative 17 is horizontal. So we all know that if the line is horizontal, the slope must be equal to 0. So we have to show that the slope is 0. So, and to find the slope, of course, we have to use the definition again. And then use the same procedure for having x plus delta x to our x here. So 2 times x squared, x plus delta x squared rather, minus 12 times x plus delta x plus 1 minus the original function, which is equal to f of x all over delta x. Then we have to again square the binomial and multiply by 2. So we have this one. And then this is minus 12x and minus 12 delta x plus 1. And then this is minus 2x squared, negative, negative, that is 12, positive 12x, and then negative 1. And then we have positive 2x squared here, negative 2x squared, and then we have negative 12x, positive 12x, positive 1, negative 1. So the remaining equation is 4x delta x plus 2 delta x squared minus 12 delta x as over delta x as delta x approaches 0. So we have to divide this by delta x, so it becomes 4x, and this 2 delta x, and then this is negative 12 since we divide the three terms by delta x. So, and if we get the limit of this 4x plus 2x, 2 delta x minus 12 as delta x approaches 0, so it becomes 0. So the slope of the tangent line is 4x minus 12. So at point 3, negative 17, so we have to plug in 3 here. So 4 times 3 is 12, then minus 12. So we have the slope of the tangent line is 0. And this means that the line is horizontal. So again, let us check. So let's have 2x squared minus 12x plus 1. This is our function. And we have point negative 317. As you can see, this is the point negative 317. And if we draw the tangent line at this point, so we have the horizontal line. And again, the slope of this line is 0. And the equation of this line is y equals negative 17. Now, so let's take a look at the definition of derivative of a function. So the derivative of a function with respect to x is the function f prime of x defined by this definition. So look at this. We have the limit of f of x plus delta x minus f of x as delta x approaches over delta x as delta x approaches 0. So what have you observed? So this is also the slope of the tangent line to the curve at a given point, right? So if you are getting the slope of the tangent line to the curve, you are also getting the derivative of the function with respect to x. And this symbol f prime of x means this it means the slope of the tangent line at x is equal to a, whatever the a is on the curve, provided that the domain of f prime is a set of all x for which the limit exists. Again, the limit exists. Okay, so if we have a problem like this, so if f of x equals 1 over 2x, find f prime of negative 3. So this problem also means that you have to find the slope of the tangent line at x equals negative 3. So see, so the slope of the tangent line and the derivative of the function. So let us solve this one. So using the definition, since the definition of derivative is the same as the slope of the tangent line to the curve, so the same procedure that we are going to use, 1 over 2x, but our x is x plus delta x minus 1 over 2x all over delta x as delta x approaches 0. So we have x minus quantity x plus delta x times 2 times x plus delta x times x over delta x. And simplifying this expression, we have negative delta x all over 2 times x plus delta x times x all over delta x as delta x approaches 0. So for the continuation, so we have we have negative delta x all over delta x times 2x plus x plus delta x. So we cancel this one. So the remaining expression now is negative 1 all over 2x times x plus delta x. But getting the limit as delta x approaches 0, so this delta x is 0, so we have negative 1 times 2x, and we have negative 1 all over 2x squared. And then plugging in, f of negative 3 is negative 1 all over 2 times negative 3 squared. So that is, the negative 3 squared is 9 times 2. So we have negative 1 over 18. So let us check here. So using GeoGebra, we have here, so 3 negative 1 over 6, this one. And then the slope is negative 0.06, and this is equal to negative 1 over 18. So if you have no question, we have a short evaluation or assessment by simple game. So to end this session, so I always remember that the best way to learn math is to do math. So thank you very much.